Hello, student.
Hello.
Today, we're going to be doing this problem right here. So what we have to do is take polar coordinates and turn them into Cartesian coordinates using a C++ program. So basically, what polar coordinates are is that you have an angle and then you have a distance from the origin that the point is. So basically, if I had a point like right here, the polar coordinate for that would be the length of this line as well as the angle that that makes with the x-axis. So what we want to do then is take this representation of an angle and a length and turn it into a triangle, a right triangle, because then we can use our sine and cosine functions to find our Cartesian coordinates, which is just our simple x and y coordinate.
Yeah. And so the only two components of the Cartesian coordinate are the angle and the length of the line.
And the length of our line basically becomes the hypotenuse of our triangle.
Okay.
Okay, so over here in our compiler, we're going to want to define our variables. So obviously, we're inputting a length of our point as well as the angle. So we're going to want to double our theta for the angle as well as r for the length. And we're going to want to transfer that to Cartesian coordinates, which is just x and y. So we'll double x and y. And to use that conversion, we're going to need radians. So we're going to want to also define rads, which is our radians. So following that, we're going to want to input our values. So we're going to say cout. We're going to say enter our theta. And then below that, we will enter theta. We're also going to want to input our length. So we'll say enter cout, enter
And we're using double because we're dividing and we don't want our calculations to get messed up.
Yes, absolutely. Good point.
Okay. And also, will we have to add another include like CMath or something?
Oh, that's a good point. We are going to have to do that because we're going to have to use trig functions for this, and CMath is required in order to use those. So we're going to want to add CMath. So now that we have our variables defined as well as our inputs, what do we want to do to our values in order to find an x and a y length? Now, if you know your trigonometric functions, you know that sine can be described as the length of the y part of your triangle, and cosine can be used as the x length of your triangle. So what you're going to want to do then is have x be equal to r times the cosine of your theta, and y be equal to r times the sine of the theta. But wait, because we missed something along the way. So basically, our theta is being inputted in degrees. However, in order to do proper trigonometric functions, we have to convert it to radians. So what we're going to want to do then is take our rads and then take our theta, which is degrees, and multiply it times pi, which is equal to 3.14 over 180, because that's the proper way to transfer degrees to radians. And so down in our...
Is that all in parentheses over 180?
No, I don't believe it is. Although I'm not sure it would 100% matter.
Okay.
So then what we're gonna want to come do is go to our formulas, and then because we transferred our theta to radians, we're gonna want to change this to rads. So after that, we're gonna want to output what we get. So we're gonna want to see out that our Cartesian coordinates are, then we want to have our x value, and then our y value. Just for formatting purposes, we're going to put a comma in the middle, a comma, but that's really only necessary to just make them clean. All right, now that we have our code written out, let's run it. So first it asks for an angle. We're going to give a nice easy angle, and we're going to say 0 degrees. Then we're going to want to enter the length of our
Triangle or line.
Yes, we're going to want to enter the length of our line, and then we're going to want to see what our output is. So we'll say it has a length of 1. So now the Cartesian coordinates are 1, 0, which makes sense because the sine of a 0 degree angle is 0, but the cosine is 1. So we should have an x value of 1 and a y value of 0.
Yeah.
Now let's try it again with something a little more difficult. Let's say 45. Let's have a length of 5. You see our Cartesian coordinates are 3.5 and 3.5, which makes sense because for a 45 degree angle, our x and y values should be the same. And thus we know we have solved it. So what you can do is save this code and say Cartesian, then save it, and you have your answer.
Okay, thank you.
Of course, student.